Okay, so this is the first question in the next topic, that is average speed and average velocity. Okay, so let's start solving this. It says a person travels along a straight road for the first half time with the velocity u1 and the second half time with velocity u2, and then the mean velocity, otherwise average velocity is. Okay, so I would actually say that, okay, let me just make a small correction here. This is not u1 and u2, let's make it v1 and v2. Okay, so we have another question. So we have velocity v1 and velocity v2. Okay, so see what I often observe is students always try to, try to mug up the formula, make it by heart, and then say that this particular equation works for this particular instant. No, that doesn't work, at least during the exam time. So what I would say is, instead of trying to by heart things, always it's better that you focus on the conceptual part. And what is the concept here? The concept is simple. The average velocity is always equal to, irrespective of the situation, is always equal to just one formula. What is that? That is total displacement upon, it is the total displacement upon the total time. Okay. And what is total displacement? See, very simple. What is the formula for displacement? Displacement, okay. What is the formula for velocity? Velocity is displacement upon time. So what is displacement? Displacement is velocity times time, right? Now let's just apply this formula here. So what we have here is, velocity is equal to total displacement by time, and total displacement is equal to velocity times time, the whole upon, what's the total time taken? Let us say the total time taken is t seconds. Now, this velocity, this motion has taken place in two different steps. The body was actually moving from A to B, but instead it took a path from A to C with velocity v1 moving for time t1 seconds, and then velocity v2 from C to B moving for t2 seconds. But the question here says that the first half time, which means that t1 is equal to t2, and both of them are halves. Half of what? Half of the original time t. So this whole displacement, I can write this whole displacement as AB, right? But what is AB? AB is AC plus CB geometrically, the whole upon T. What is AB now? So, sorry, what is AC? See, AC is this path traveled. AC is this path traveled. And what is this much path? This is equal to, the displacement here in AC is AC. And what is the velocity? Velocity is V1. And what is the time? It is V1 times T1, right? Or in other words, let us see the other way around. In the case of motion along CB, what is the velocity? Velocity is V2. What is velocity is equal to? Total displacement by total time. What is the total displacement? Displacement is CB. What is the time taken? It is T2. Now what is the measure of CB then? For the measure, CB would be now equal to V2 times T2. Simple. Now, in which case we can say that AC is basically V1 T1 plus what is CB? CB is basically V2 T2, and the whole upon this becomes T. Right? Now, if we go further, what is V1 T1 plus V2 T2? We can say that V1 times, what is T1? T1 is T by 2. Why? Because we just said it's half time, plus what is V2 T2? T2 is again half time, so this will become what? This will become T by 2 and the whole upon T, which further becomes, see, what you can do is we can take T common from the numerator, right? So T will be common from the numerator, and if we take that T outside, what do we have? We have V1 by 2 plus V2 by 2, the whole upon T, which basically means that T and T will now cancel off, and what will we get? We'll get V1 plus V2, the whole upon 2. Therefore, the final average velocity, or the average velocity for the entire motion would be the what? Would be the mathematical average, right? The mathematical average of the two velocities. Well, I think it is only an equation where actually the average velocity literally means the average velocity. Okay, so this is a very similar question similar to the one that we did some time ago. That is question number one, which is basically based on travel of a body, motion of a body from point A to point B, but in equal intervals of time, right? Here, instead of equal intervals of time, we have been given equal distance, one third of the distance, the second one third distance, and the remaining one third. So what I would suggest is pause this video, take down the question and try solving it. And as usual, don't try to mug up the formula by referring other textbooks. Just do this one step. Average velocity is equal to the total displacement upon the total time. And how we'll do this? You will first draw a rough diagram, mark the point, initial point as A, final as B, the midpoint as C and D, and then you can, figure out what is the total displacement, mark those displacement, and then mark the individual velocities. It will be easy for you to solve the question. So pause the video now, start doing it on your own. So if you have done the question, it would look something like this. Let me just draw a rough diagram here. So this is a rough diagram. So the body is moving from A to B in equal distances. So let us say this was C and this is D. Okay. So A to B, let me take this entire distance A to B as 3x. In which case, how much would be A to C? It would be x. How much would be C to D? You're correct, x again. And how much would be D to B? Right, x again. Okay, now it's given the question that A to C is covered with velocity v1, C to D with velocity v2, and D to B with velocity v3. Okay, now let us say that the time taken to cover was A to C t1, C to D t2, and D to B t3. In which case, and also the total time taken for this travel was t. Okay. Now let's write down what is average velocity is equal to. See, we know that average velocity is equal to the total displacement. The total displacement upon the total displacement, the whole upon the total time. Now, what is the total displacement? The total displacement is AC plus CD plus DB, the whole upon, what is the total time taken? It is T. Now, how much is the total displacement? The total displacement is AB basically, and the total time taken is the sum of T1 plus T2 plus T3, right? And how much is AB? AB according to the question is 3x. So we can write it as 3x, the whole upon. What is T1? See, for the motion along AC, what is V1 is equal to? V1 is basically equal to the displacement, that is AC, upon time, that is T1. So what is T1? T1 is basically equal to AC upon V1. What is AC? AC we have taken it as x. So this will be x upon V1. Right? So let us continue this question here. So T1, we can replace T1 as x upon V1. Now can you tell me what would be T2? Which is the motion reference from C to D. T2 would be T2 would be x upon V2, and very similarly T3 would be x upon V3, right? Going further, this would result in, let me write also 3x in the numerator, and denominator we can take x common. So what do we have rest? So we have 1 by V1 plus 1 by V2 plus 1 by V3, right? Now further we can write this as, now I don't want to solve the question in one single step because I believe these are the very simple questions and those who are watching it are doing it for the first time. So I'm going to I'm going to write each and every question more times. with more steps. Okay, now what will be the LCM here? The LCM would be V1, V2, V3, right? And what would be the first numerator? The numerator here, when you divide V1, V2, V3 by the denominator, that is V1, what will cancel off? V1 and V1 will cancel off. So now you will multiply the numerator with V2, V3. V2, V3 plus, what will be the LCM? The LCM is V1, V2, V3, and what is the denominator? It is V2. So what will you divide it by? You will divide it by V2. Now what will cancel off? V2 will get cancelled off, and what else will you get here? V1, V3, right? So you multiply the numerator with V1, V3. So here you write it as V1, V3. We don't need to do the third part. It would be V2, V1, right? Now, in this case, we can say further that x and x will get cancelled. So what will we get? 3 the whole upon. Let me just make a small rearrangement here. I would write it like this. V1, V2 plus V2, V3 plus V1, V3. Okay? The whole divided by V1, V2, V3. Okay? Now, this can further be written as 3 times V1, V2, V3 the whole upon V1, V2 plus V2, V3 plus V1, V3. So the average, this would be the required expression for the average velocity. Okay, so we did 2 questions on average spin and average velocity. Now, let's try a similar question, similar to question number 2. But this time, I would suggest you to pause the video and try to find the answer on your own. You can directly use the formula that is derived in question number 2, or you can do it, try doing it on your own, the entire question on your own. That's up to you. But I would say don't follow the video as of now. Pause it and then resume once you have completed the question. Anyhow, I would be doing the question in the elaborate way so that all students can understand. You may skip that part and go to the answer where you just apply the formula. Okay? So having said that, let's move on to the next question here. A body covers first 1/3 of the distance with a velocity of 20 meters per second, the second 1/3 with a velocity of 30, and the third with a velocity of 40. The average velocity nearly is. Okay, so let's start solving this question. So, as I always suggest, make sure that you draw a diagram so that things becomes easy for the calculation. So the body is moving from A to B. Let us say it's C, it's D, and let us say the distance is 3x. And let us say this much distance is x, CD is also x, and DB is also x. A to C is moving with velocity v1, C to D is moving with velocity v2, and D to B with velocity v3 in corresponding times t1, t2, and t3. Now, we know that average velocity is equal to the total displacement upon the total time. Now, what is the total displacement? It is 3x. What is the total time taken? It will be the sum of t1 plus t2 plus t3, right? Sum of t1, t2, and t3. Now, what would t1 be equal to? Now, I don't need to elaborate how to find the value of t1. Okay, let's not skip that part too. So for the motion along AC, what is displacement AC? AC will be, sorry, what is velocity? Average velocity V1 would be equal to AC upon T1, right? So what would be T1? T1 would be AC upon V1. What is AC? AC is X. So what is T1 is equal to X upon V1, right? So let us now put this value in the equation here. So T1 is basically X upon V1. What would be T2? Would be corresponding X upon V2. What would be T3? Would be X upon V3, right? In which case we can write further that if we write this 3x common and we take x common out from these two terms, what do we get? 1 by v1 plus 1 by v2 plus 1 by v3. Now should I explain it more? Okay, let me just do that also. Let us not. Okay, now how much would this be equal to? This would be equal to 3x the whole upon x times. We know that the LCM is v1, v2, v3, right? And here it will be v2, v1 plus v2, v3 plus v1, v2. I don't need to derive this again. X and x will get cancelled. So what will be the final average velocity? It would be nothing but 3 times v1, v2, v3 the whole upon v1, v2 plus v2, v3 plus v3, v1. And those students who have a doubt here, I think I just made a small error here. v1, v2, v2, v1, v2. This is not v1, v2. This is v1, v3. Sorry for that error. Okay, so now in this case, this can further be written as, according to the question values here, 3 times 10 times okay, let me just cross check the values. It's 20, 30 and 40. Okay, so 3 times 20 times 40 times 20, 30 and 40. Okay, so 3 times 20 times 30 times 40 the whole upon 20 into 30 plus 30 into 40 plus 40 into 20. So this would be 3 times 12 is 6, 18, 18 fours are 72, right? So we have 72,000 the whole upon 3 into 2 is 6, 600 plus 4 threes are 12,200 plus 4 twos are 8, 800. So this will further be equal to 72,000 whole divided by 600 plus 1200 is 1800 plus 800 is 2600. So these two zeros will cancel off, and what we will be left is with 720 upon 26, which if we can cancel and divide both numerator and denominator by 2, what do we get? You will get this as 360 upon 13. So if you divide 360 by 13, you will get this as 13. 2 times is 26. So you're left with 100. And 13, 7 times is 91. So you get 7 times 91. So we left 9, 90, which again would be 13 times 6. So it's approximately equal to 27.6, which we can round it as 28. So the correct option to this question would be option A. A particle moving in a straight line covers half the distance with speed 4 meters per second. The other half of the distance is covered in 2 equal time intervals. Mind you, 2 equal time intervals with speed 5 and 7. The average speed of the particle, during this motion is. Okay, so see, so far we were doing questions which were either based on motion of a particle covering a particular distance in 2 equal halves, or covering a particular distance in two equal time intervals. But this question is a combination of both. So we'll do more of more kind of such questions, but this typically is a it just brings up the previous 2 to 3 questions that we have practiced, right? Now this will enrich your concepts. These kind of questions will enrich your concept, and students often ask me this question: how do we feel confident that given that all of a sudden a new question comes up? That comes through practice. What kind of practice? Practice of doing questions in this manner. Okay, so let's start solving this question. So it goes like this. Let us first mark a typical diagrammatic representation. So let us say the body is moving from A to B, okay, and let C be the midpoint. And as usual, let us say 2x is the distance. Why did I take 2x? You can go for x either, but I would say I would stick on to easy calculations. So in which case AC here is going to be half the distance, that is x, right? And CB is also going to be x. Now AC is covered at the speed of 4 meter per second. CB is covered in two equal time intervals. So let us say that, okay, so let us say the body was T1 for this long and T2 for this long, okay, and T1 was covered with a velocity of 5 meter per second and T2 with a velocity of 7 meter per second. Let us check for the dimensions. All the given are units are given in meter per second, and the answer is also in meter per second. Okay, now we know that average velocity, right? Average velocity is equal to the total displacement, the whole upon the total time taken, right? Now total displacement here would be AB, the whole upon, what is the total time taken? Let me just write it like this: time taken to cover AC plus time taken to cover C, let this be CD, which is basically what we have taken as T1, right? And then we have time taken to cover DB, which is basically T2. Okay, let's talk something about T1 and T2. See, T1 plus T2 is a special value. Can you tell me why? Because both the time intervals are equal, so it can be written as T1 plus T1, in which case we can say that this is 2 times T1. Okay, now what is AC? What is CB? See, we can say that CB is basically the distance covered in the second half. How much would be CB? CB, we can write this as CD plus DB, right? Now what is CB? CB is X. What is CD? CD is 5 times T1. Now if you ask me why, simple. What is distance is equal to velocity into time. What is the velocity? 5. What is the time? T1. I repeat myself, what is distance is equal to, or displacement is equal to velocity into time. What is velocity? 5. What is time? T1. What is the displacement? CD. So CD would be equal to 5 times T1 plus, what would be DB? I would repeat it again. DB is the displacement. What is displacement is equal to velocity times time. What is displacement? DB. What is velocity? 7. What is time? T2. So we can write this as 5 T1 plus 7 T2, right? But what is T1 and T2 connected as? They are equal, right? So we can write this as 5 T1 plus 7 T1. So basically we can write X is equal to 12 times T1, which further implies T1 is equal to X upon 12, right? So we can also write T1 plus T2 as 2 T1, right? So T1 plus T2 would be now replaced as 2 times t1. Now, what is 2 times t1? t1 can be replaced by x by 12. So going further, we can write this as AB is 2x the whole upon. What is TAC? AC is the displacement. What is the velocity? 4 meter per second. What is the time? What is the time taken to cover this much? The time taken to cover this much would be distance upon velocity, that is 4, plus 2 times. What is T1? It is x by 12. So what can we say further? We can solve this by saying that x will cancel upon in every term. And what do we have rest? We have 2 by 1 by 4 plus 1 by 6, right? So this would be equal to 2 by 10 by 24, which will be equal to 2 into 24 upon 10, that is equal to 24 upon, okay, that is equal to 48 upon 10, which is 4.8 meter per second. So the correct option here is option C. A car covers 1/3 distance with 20 km per hour and 2/3 distance with 60 km per hour. The average speed is, okay. So now let's start solving the question. As usual, we'll first check whether the units are consistent with the given options. So 20 km per hour, 60 km per hour, and all the options are also demanding km per hour. So we can directly start solving the question. My bad, that small error that in the options. Okay, now let us first draw the diagram. So the car starts from A, it moves up to B, okay, and I'll take this entire distance as 3x. Somewhere over here is C, the next is T. Car covers 1/3 of the distance. Now those people who are actually still confused why it takes 2x and 3x, you can start breaking down the question again. So see, 1/3 of the distance would be 1 by 3 times 3x, which would give me x, right? And what would be 2 by 3 of the distance? 2 by 3 of the distance would be 2 by 3 into 3x, which will give me 2x. Okay, so what is AC? AC is 1 by 3, so this much distance is x. And what is CB? CB is the rest of the distance, which is basically 2x. Okay, now we can write that the average velocity is equal to total displacement by total time. What is total displacement? The total displacement is AB, because the body is moving from A to position B. What is total time taken? The total time taken would be the sum of time taken to cover AC from time to cover CB. Now, what is time taken to cover AB? Time taken to cover AB would be, time taken, what is AB? AB is 3x. And what is time taken to cover AC? See, what is velocity equal to? Velocity is equal to displacement by time. So what is time is equal to? Displacement by velocity. In this case, AC is the displacement. So what is the displacement? It is x by, what is the velocity? Velocity according to the question is 20 km per hour. So we can write this as 20 plus, what is CB? Time taken to cover CB. Time taken to cover CB will be displacement CB. What is displacement CB? It is 2x the whole upon. What is the velocity? It is given as 60 km per hour. So this becomes 60. Okay. Now we can say further that this is equal to 3x the whole upon. Okay, let me cancel x from numerator and denominator because it is present, right? So we can cancel off x, which is present in both numerator and denominator. Then what are we left with? 3 by 1 by 20 plus 2 by 60 would be, okay, let me just write 2 by 60 alone, and then I'll multiply this 3 in both numerator and denominator. So what do you get? 3 upon 3 by 60 plus 2 by 60. And how much is that? That would be 3 by 5 by 60. And what would that be equal to? 3 by 5 by 60 is 3 reciprocal of 5 by 60, which is basically 60 by 5. Okay, so 5 times 12 is 60, and we get the answer as 36 kilometer per hour. So the required V average is equal to 36 kilometer per hour. So the correct option is option C. A car travels half the distance with constant velocity of 40 km per hour and the remaining half with a constant velocity of 60 km per hour. The average velocity of the car in kilometer per hour is. Okay. So let us first draw a rough diagram so that we can understand the question what it is more clearly. Okay, so let us say the body is moving from A to B. The half distance is at C and it covers, so let us say this much distance. AB is basically 2x, right? So what would be the half of this? Half of this AC would be equal to x and CB would also be equal to x. Now what other details are given? The first half is covered with a speed of 40 km per hour. The second half is covered with a speed of 60 km per hour. Okay. See, now those who are watching this video, you can solve this question right by applying the formula, but see, the whole purpose of the series is to make sure that you've been given questions to practice enough, in a sequential manner, so that you try to solve problems faster, not by doing problems in a faster manner, but by doing so many problems that the calculation becomes automatically faster for you. Okay, so those who directly know the formula, you can do it. Others can watch the video and then go on to the next video and slowly improvise your speed. Okay, so we can say that the average velocity, right? So the V average is equal to the total displacement, the total displacement upon the total time. Now, what is the total displacement? The total displacement is AP. Yes, I can write it as 2x in the very first step, but that's what I was telling you a minute earlier, that the intention is not to solve the question as quickly as possible. The intention is to explain solution as clearly as possible. Okay, so those students who feel that you want a faster solution, you can either pause the video and check the answer directly, or maybe you can put it in 2x mode. But others, please be with me. As we do more number of problems, the speed to solve the speed in solving the questions will definitely go, in a very higher pace. Okay, so we have AB whole upon, what's the total time taken? Let us say we don't know the total time taken, so we'll split it into two: time taken to cover AC plus time taken to cover CB. Now let us substitute. What is the measure of AB? AB is 2x. So we have 2x the whole upon. What is AC? AC is x upon 40. Why? I'll explain that also. See, velocity is displacement by time. So what is time? Time is displacement by velocity. Along the path AC, what is the displacement? The displacement is AC. What is the velocity? The velocity is 40. Simple. Okay. Likewise, TCB is also displacement by time, that is x upon the speed is 60. Okay. In which case, in which case, we can further say that this is equal to 2x the whole upon. I'll take x as common from both the numerator and denominator. Sorry, from the denominator. So what do we get? We get 1 by 40 plus 1 by 60. This is further equal to, now x and x will cancel off. What do we get? 2 the whole upon 1 upon 40 plus 1 upon 60. This will further be equal to 2 the whole upon 60 plus 40 the whole upon, oh, I'm sorry, the whole upon 2400, which will be equal to 2 into 2400 the whole upon 100. So these two zeros will cancel off and we'll get the final answer as 48 kilometer per hour. If a body travels half the distance with velocity v1 and the next half distance with velocity v2, its average velocity will be given by. Now, let us draw a rough diagram to analyze the motion. So, let's say the body was at initial position A, final position B, C was the midpoint, and let us assume that the whole distance is 2x, in which case AC would be x because C is the midpoint, C is half the way, and CB is also going to be x. Okay. Now, it travels half the distance with velocity v1. So AC is traveled with velocity v1 and CB is travels with velocity v2. Now what we can do is we can write the formula for average velocity. So average velocity is given by, the formula for average velocity is given by nothing but displacement upon the time. Now, what is the displacement? Displacement is AB. What is the time? Time taken is time taken to cover AC plus time taken to cover CB. Now, what is time taken? What is displacement AB? AB is 2x. What is time taken to cover AC? Time taken to cover AC. See, time, velocity is displacement by time. So what is time? Time will be equal to displacement upon velocity. In which case, time taken to cover AC would be the displacement AC upon V1 plus time taken to cover CB will be displacement CB upon the the velocity, that is V2, which further means 2x the whole upon AC upon V1 will now become x upon V1. Why? Because we know that AC is equal to x plus we'll have x upon V2. So this further becomes 2x the whole upon x times 1 upon V1 plus 1 upon V2, which further will reduce to x and x get 1. So this becomes 2 upon 1 by V1 plus 1 by V2, which basically equals to 2 times V1 plus V2 upon V1 V2, which is basically 2 V1 V2 the whole upon V1 plus V2, which makes the correct answer as option C. A man walks with a speed of 4 km per hour for first kilometer, 6 km per hour for the next 1 kilometer. His average speed for the 2 kilometers is. Okay, now those students who have followed the video series till question number 7, you should be able to figure out the answer directly in your mind without drawing the diagram, without solving the question in detail. And this time, unlike in the past question, I too would be increasing the speed of my the way to solve the speed of solving the problem. So let me, okay, yet let's draw the rough figure. So A to B is 1 kilometer. Sorry, A to say so A to C is 1 kilometer. C to B is also 1 kilometer. We know that the average speed is equal to total distance by the total time taken. The distance is given as 2 kilometer. Time taken would be 1 by 4 plus 1 by 6. So this basically would give you the answer as 2 times 4 times 6 the whole upon 6 plus 4, which is basically equal to 48 by 10, and thus the answer is 4.8. So the correct option would be option B. Okay. Now, this is how you should be, gradually increasing your speed. So, see, if you observe, I could do this question in a faster way, not because I did the question very fast. It is because I know that I've done similar questions many times, well, at least 7 times, considering this video series. I've done it at least 7 times. So the eighth time, I need not draw the figure in detail. I need not write the dimensions in detail. I need not write the speed with reference to every half year. If in fact I can even skip this step. Now, if such a question comes for the test paper, you should now directly be able to use the formula 2v1 v2 the whole upon v1 plus v2. In this case, this would be 2 times 4 times 6 the whole upon 4 plus 6. So that's what you do while you study. You learn to solve the problems, then you do the solution quick, and then you make it in one step. Okay. Okay, so I hope the methodology was clear. Now let us go to another problem. A car moves 200 kilometers. It covers the first half of the distance at speed 40 kilometers and the second half of the distance at speed v. The average speed is 48 kilometers per hour. Okay, so very straightforward question. Now, see, since this is the question number 9, I can't, start writing the entire formula once again, because that is meant for problems which starts from question number 1. So if you're directly watching this video question number 9, and if you find it difficult, it simply means that you haven't covered the basics. So for those people who find this question difficult, please make sure you go to the previous questions and then only come back to this video. Okay. For others, those who have done the question 1 to 8 and those who have written the notes well and those who have calculated the problems on their own, for them, whatever I write should be a continuation of their mental thoughts. That's it. Okay. Okay. Now, if I have to write the answer, I would say that V average is equal to 2 V1 V2 the whole upon V1 plus V2. The given average is 48 kilometer per hour. So we have 2 times the first speed is given as 40, v2 is given as v whole upon 40 plus v. So if we cross, would give, okay, let us now, better that we cancel the both sides of the equation by dividing by 4. So 48 divided by 4 will be 12, 40 divided by 4 will be 10, right? And okay, so we have 12 is equal to 20v by 40 plus v. So we have 2 times 4 times 3 is 12, 4 times 5 is 20. So now we have 3 into 40 plus v is equal to 5v, right? So we have 120 plus 3v is equal to 5v. So 120 is equal to 2v, and therefore v is gonna be 60 kilometer per hour. So the correct option is option P. A car moves 200 kilometers. It covers first half of the distance with speed 60 km per hour and second half of the speed at v. If the average speed is 40 km per hour, the value of v is. Okay. So a direct continuation, in fact, direct, I would say it's almost the same as question number 9. So I will just start answering the question by writing the formula for V average, right? V average is equal to 2 times V1 V2 the whole upon V1 plus V2. What is V average given here as? The average speed here is given as 40 km per hour 2 times. What is V1? V1 is given as 60 km per hour 60. And what is V2? V2 is given as V whole divided by 60 plus V, right? So 20 times 2 is 40, 20 times 3 is 60, 2 times 2 is 1, right? So all we have is 60 plus V is equal to 3V. So 60 is equal to 2V, and therefore V is equal to 30 kilometer per hour is the correct answer, which means option A is the right answer.